So yes, I think we can start. So yeah, the floor is yours, and thanks again for being with us.
Hi everyone. Sorry I couldn't be there. I really wanted to be there, but my schedule didn't allow me to travel. Very happy to be joining. My name is Ayşe Deniz Lokmanoğlu, and today I'll be talking about topic modeling in RStudio. I did upload the whole code on GitHub, so it should, and I made the slides using the same code, so you can run it along and it will work the same. Yeah, I did see some of you added topic sentiment analysis, so I added just a few sentiment nodes at the end that wasn't there. I'll upload that after class as well, if anyone is interested. I also still cannot see the room, so I'm just gonna, if there's any questions or anything, just like
Yeah, we'll be here also to
yeah, exactly.
There are
So great. So first, what I wanted to start with, is everyone familiar with text analysis? Has anyone used R? You can just raise hands and someone could tell me.
Yeah, I see like maybe 6, 7, maybe 10 hands raised hands about R. So yeah, we have to say that so far in the first 2 days, we have seen mostly and only Python. So this will be the first R lecture. So
okay,
there's, I would say like about 10 people who have already some experience, but others that probably it's the first time they see
R. Okay, great. So I did upload also an introduction to R sheet to our GitHub page, which if you're very unfamiliar, that can help you. R is very similar to Python, I will say. But when I was being taught R and Python, in both of my teachers always said, forget all you know about Python and forget all you know about R. It is just learning like a different language, but they are very similar. And I think as time goes by, the packages are becoming even more similar. So I think it's very easy to interchangeably use both. So I use mostly R in my own research because I do mostly text analysis combined with regression and other statistical analysis. So it's easier for me to have them all in one place. But I do also, for example, use Python in different cases. So today we'll be, like I said, we'll be using R, and we'll actually look at how we can derive detailed information from a somewhat large corpus. I kind of simmered it down a lot, so it will work today in today's class. And we will see what we could do with topic modeling and what is topic modeling in the first place. So topic modeling is something we call a bag of words approach. A bag of words approach literally means it just puts all the words in a bag, and it doesn't have, it doesn't consider syntax location or anything else when it's actually developing. The algorithm or the allocation it uses is called Latent Allocation, which I totally butchered it probably, but it's just a computational tool that surfaces what you call hidden semantic structures in a collection of text. And I think I like topic modeling myself because one, it's inductive. So, and does everyone know, is everyone following? So it doesn't actually give research bias. So previously when you did textual research, it will be researchers actually assigning codes and topics in the same manually. What topic modeling does is it actually takes the researcher bias out of that, and it does it computationally. The other thing that it does is it actually gives you 3 levels of information. So the first one is corpus level information. So it gives you information on the whole corpus. And then it gives you document level information. And in this, we call it document. The document represents anything that you put in. It's your unit of analysis. So it could be tweets, it could be articles. In this case, we're going to look, it's going to be news articles. It could be scholarly articles. It could be citations. It could be chapters. So it is your unit of analysis. It is what you pick to be your unit of analysis. Let's put it that way. And the third level of information it gives is actually called terms. So it is literally the terms, the words. And if you think about it, they all add up. So the corpus is collected by documents, and the documents are the collection of words or the terms. And when you think about it, then the algorithm gives you these 3 level information. So it gives you how words are represented within the topics, but also how within the documents, but how documented are represented with the words within the corpus. And I made a very bad visualization in the next slide, which if you are in the GitHub page, you would have seen, but I hope it makes a bit clearer. So that's why topic modeling is preferred, because it both uses the words, but it also uses each of the documents. And it also allows each document to represent multiple topics, which I think is very important. So topics are not mutually exclusive.
Sorry.
Are
you showing slides? Because we do see only the RStudio window.
Oh, okay. That is, thank you.
Yeah.
Here you go. Okay. It was only, yeah, it was only one slide. Thank you for that. So, and I did upload the slides on GitHub also, so they're all there if for following purposes. Exactly. So it actually, so what is really good about it is, and think about it intuitively. If we think about it, one tweet does not only have one topic in it, right? It could have multiple topics. It could be about COVID, it could be about masks, it could be about vaccination, for example. When we're thinking about, it could be about, it could have multiple topics in it. So LDA helps us actually, LDA allows multiple topics to be represented in each document. And this was a bad visualization I was talking, and thank you for catching that I wasn't showing. So what it does is it takes documents and then it creates a bag of words. And then from that, we first get cluster of words by topics, which we will call K. So it's K number of topics. And we also get, as you can see, what each document is, what each document has. So document one, how much of it, how much of each topic each document has. So is there any questions till now, or should I continue? No questions? Okay.
Seems okay. Yeah.
Okay, perfect. So let's start coding. So did anyone have a problem with the GitHub page or the code? Okay, so I assume it's run okay. So the first thing we have to do in R, like Python, very similarly, is we have to install our packages. But you only have to do this once. So installing packages, you only have to do this once for every time you get a new computer, every time you update R sometimes you need to do it. But other than that, you don't really have to install packages. So when you install your packages, it adds them to the R library. So in this case, these are the packages we're going to be using. And some of these packages are packages that I always use, such as tidywords, dplyr, ggplot, lubridate. So those are, and I actually made a note of each of the packages descriptions. So after you install the packages one time, every time you open R, you need to load your packages in. So you need to load the packages you're using. So in this case, we're loading all of our packages. And if you need to actually know or learn about a package, in R, it's very easy. You just put a question mark and write the package name and press Control Enter. And it will actually give you the package name. And let me try to show that to you. Okay. So, and do you now see on the on my right hand, it actually says tidywords, easy install. And then from this, you can actually go to its own package to own GitHub page. You can do this with also every single function. So you can do it with every single command. You can actually do this, and I will have more examples of it throughout the thing. So if you don't load a package, R will not know what to run, what command to run. So so you always need to load your packages. So our data set is, I uploaded it to Harvard DataWorks, and you can load it with this link very easily. And it's actually a data set, and I actually shortened it a lot. I used a sample of 1500. It is a data set of text we collected across a year about COVID-19 in US. So these are all news articles, online news articles, and then we scrape them actually. So there was a lot of pre-processing done with this data set itself. This is just a glimpse of it. We also had other information, but you can see the first one, for example, says Chicago mayor needs to dump police boss, continues. You can look at the data set more in your own R environment. So one good way of doing that is you can actually go and you can click on the arrow, especially in bigger data sets. I would never recommend opening in the viewer because it will crash your computer, but you can see the index and the original text. And the other thing you can always do is you can always look at head my data, which is also very similar in Python. And it gives you the head, as you can see, and then it gives you the text. Does anyone know what these little numbers are? Can anyone tell me what these are? Why do we have like this little code here?
Any idea of the mean?
Okay, so these are things that R actually couldn't read as text. So they coded, this is similar to like a color hex code. So it gave a code to it. So what we usually do is, and in this case I didn't, but you can actually convert all your text to, you can convert all your text to R format, and it will actually read those. So I will now go back to the slide. And if any point you have problem following along the code, please stop me. It's easier to address the topic when we're actually on the topic. So what now we're going to do is, we did see in this data, we have this like weird column that said ... 11, right? Does anyone know why this comes? So R, when you upload CSVs and Excel, it will actually upload the index column in its index row in itself. So this is a column that comes with loading CSVs in Excel. So what I usually do is I actually get rid of that column. And to get rid of the column, I literally say select and then put a negative sign, so drop. So it's very easy to drop a column. You just say select and drop. And then what I did was, so R needs to, when you're working with dates, it needs to read it as dates. So to do that, there is a very beautiful package called looper date, which we loaded in the beginning. And in this case, ours was already in year, month, date format. So I just said, my date is year, month, date. So just characterize it as date. And you can see it changed it to date. And then what I do, and this is a personal choice, you can do it, you can't do it. This is how my mentor taught me, so I always do it. I always create a new column called original text. Because we're going to be playing with our text column, you don't want to lose your original text, and you don't want to down. And this is, I know this is a smaller data set, but usually the data set you're working with is so big that it takes time to upload again and then rerun everything again. So it is always to keep your original text in a safe column called original text. So if you do a mistake, you can just rerun the original text. You can just copy the original text to text. So now I have, you can see my new data set has 5 columns. I have source domain, original text, text column, which is exactly the same, an index column, which came, that was my own index for our project. And does anyone see that I did something different in this code? So I added the package name before select, and you can see in none of these, I didn't add looper date, I didn't add anything. So why do you think I added the package name before?
Maybe if you declare is not, you will not be able to declare software complete or concept from that library software complete. So not installing it as maybe installing it maybe slow the program. Well, my mind.
I heard parts of it, but I think you got it correct. So I'm gonna assume it's correct. So exactly. So there's different packages that you select, and select is one of those that confuses, like it because it's a very common command name. So with select, it's important to actually specify which package I'm using select from. Was that right? I didn't hear it, but I did like a big assumption there. From what I heard. I heard you say library and package, so I was like, so for example, in other ones, like in Lubridate, it's not a problem. And R will tell you when it's a problem. R will give you an error. And if it gives you an error, you can always look at one, your text, and two, and then what you wrote, your code, but then you can see if the package is actually, you can select the package name to see if it's there or not, if it's from that package or not. The other cool thing about this specific command with the ... with 2 semicolons is that if you don't want to just load a package, so if you just want to use one comment from a package in just one line of code and you don't want to overstress your R, you can just use this and you don't ever have to load your package. So you can just use that for one line and R would just go to that package, use it, and will not actually load the package in your environment. So especially, so like I said, if you're using only one code from one package, only in one line, this is a better way to utilize the efficiency of your R rather than loading everything from the start. So that's why sometimes in people's codes, you'll see this pop up and sometimes you won't. And that is why. So let's continue. And then, yes, exactly. Sorry, I didn't see the chat. I just saw the chat now. So the first thing we do is we tokenize it. And tokenize it's the name. It's very, you can see it's very straightforward. It literally just takes our text column. And then I included remove punctuation, remove symbols, remove numbers, remove URL, remove separators, split hyphens, include doc vars, which I will talk about it. And then the other thing I did was I removed stop words. Is everyone familiar with stop words? So stop words are words that we use that are filler words. So they're like the, and, a, to, from. So words that actually have no meaning for us in this case, but they are there, a lot of it. And stop words package works in nearly now all languages. I have used it in Arabic, I've used it in Spanish, I've used it in, we've used it in a project in Russian, actually in Russian native speaker, so that I didn't know. I've used it in Turkish text, so it works with multiple languages. And it's constantly updated. It's a part of the tidy text environment, so it's constantly updated. You can add your own stop words to this as well, and we can talk about that later if you want to. So if there are words, for example, in your text that's going to appear. One issue we had, for example, with the Russian text that our native speaker co-author made us aware was that the stop words package didn't have the days of the week and the month name. So they were all coming up in one topic. So for example, we added them manually to our stop words package. And then the second thing I do is I say, remove everything that's less than 2 characters. And that's in English makes sense. And I will say, take that for every language you're working on. You need to decide about that. In English, it makes sense because 2-letter words are usually either acronyms or they're stop words that didn't get picked up. So talks is, so talks is literally, you can see. So it says text 1, Chicago mayor needs dump police bus. So do you remember text 1, what it was before? Let's go up. It says Chicago mayor needs to dump police if. So you can see it took out if, for example, but it just took text 1 and just made it word by word. So that's what it just tokenized it, as you can see, and it did the same for the second, for the third. And in this case, you can see why I didn't do minimum character tree. So because, for example, in this specific one, we have CEO, we have CDC, we have a lot of words that actually are 3 letters that actually matter to my corpus. Okay. So then the next step we do is we change it to document matrix. And I hyperlink this, and you can go into the Quantata dataset to see. A document future matrix is what we're going to work with. And it creates the basis of our LDA. So and it's very easy. You just say, and I named my document DFM count, and then you just say DFM our talks document. So this document, change it into it. And then I always remove the variables that I don't work with. One, I work with very large data, so I want my R to run efficiently, and I don't want to overstress it and crash it. So I recommend that, but also be careful with what you're removing if it's something you're going to need for the future. So when you're first starting out, I would say try to keep, but then try to start removing. And then the other thing I did is, remember I had an index column. So what I did was I said in my document feature count, change my document name to my index column. And you're going to see why I did this. But so the one thing I'm doing is I'm equating my original data with now this new variable that I'm creating. So I can always match if I have the index column. And you can do your index. I number my index columns. I just do 1 to n. So I just number. But I have seen other people do doc hyphen. You can do tweet hyphen. So you can do multiple things with your index. You can name it however you want. That's a personal choice again. So then the other thing is I convert it to LDA. Doing LDA requires a lot of converting, so I am sorry about this in advance. It's just we just keep on converting to a new variable, but this is the last one. We're done. This is the last one. And now what I'm saying is I'm just saying take my document feature matrix and convert it into an LDA object. And you can see the code is very straightforward. We're changing it to topic models, and my doc variations are what already was there. And I always look for the number of rows, and then you can remove the document feature matrix. And you can see my LDA object now is, it has, again, 38,025 words, and that's from 1,500 documents. And then my terms is 9,225 unique terms. And then my sparsity is 100%. My maximum term length is 22 characters, so I have a very long word apparently. And my weighting is term frequency. I am continuing, people. If you have questions, jump in. We're going to now run the topic model. Okay. So this I ran for you guys. I'll say that because this takes time. So when you're doing your own project, I will say give a good time for this. And you can, yeah, I just in the code I marked it as evaluation false. So if you want to run this, you should erase that so it will run. Currently it's not running. So what this does is this comes from a package called LDA tuning. And what it does is it actually uses 4 matrix, Griffiths, ComQuant, Arun, and Devout. They're actually all papers. You can find the citations on their website, on the LDA tuning website. And it runs each of your terms with your document to give you a visual representation that allows you to find the optimal number of topics. The system times is just what I timed the system. I then save my results, and then it actually has its internal plotting feature, find topic numbers plus, and then you can save that image. So the image for ours was this, and you can actually see this is not a great one. So one, it shows that our corpus is, I didn't run enough numbers. I should have run more topic numbers to make this graph bigger. Because you can see how the ComQuant is actually a bit squiggly. So they should be more curvaceous, I guess that's the word. But in this one, if I didn't have time and if I had to run with this, I would use something like 22 because it seems like it's bowing down and upping up here. Or I would do 37, something in between. I would pick the number of topics. I will say this is the first find K. I personally don't use this one. And if you want to use a more complicated one, I have the code for that. We now use a different matrix where we cross-validate. So it's a bit more complicated. So I didn't want to run with that. But this is also a very reliable one that's been used and that's been reviewers actually accepted. So and you should provide. So, but yeah.
One simple question would be like if you run these models, they have like now you have like k equals 5. You set the random seed, but those are obviously not the whole list of parameters for LDA, right? So you would have an alpha and beta there as well, and that might have a huge influence, like in terms of what's right for a suitable number of topics you need to describe it for. Do you have any recommendations, or does it influence at all, or what is your feeling there? And one other question would be, there are models that estimate the number of components as part of the inference, like the HTTP, the rapid theoretical process. Would that be something worth looking into as well, or what's the difference there?
So I cannot hear anyone in the audience. I think because I'm hearing from the laptop thing, but if someone could reiterate me close to the laptop, I would appreciate it. Or if you could come close to the laptop. Sorry, I was trying really hard and it's not.
Sorry, I was using the wrong microphone. I was just those graphs you were showing, they were really important, I think. And do these, I could basically find the optimal number of topics, and in your graph it seems like 22 seems to be the right number, right? So 22.
So I picked 22 for this, looking at this graph, but I would still run, for example, 32 and 37 and look at the three models. So I always,
From what kind of input parameters does it depend on? It obviously depends on the corpus you're using. Maybe like some corpora require a higher number of topics, but it might also does it also depend on like other parts of the input? Like, for example, LDA itself requires alpha and beta, those variables, those prior variables to be set. Do they have an influence as well? So when do I know that the 22 that's coming up here or the 37 is the right 37? And how much, or is it something, how do I pick it?
So one thing is yeah, exactly. You look at your corpus, for example, you look at how many boilerplate topics there are, or if you see if it's too little. So if 22 has it becomes too generalized. So I would say that one. The second thing I would say is in this specific method, the alpha is set. In the method we use now, we actually try different alphas starting from 0.01 to 0.5. So if you're doing a more complicated especially if you're doing a more complicated project, I would actually recommend you use that code, not this one, and try different alphas. Like I said, I can email that code if anyone's interested. But in this one, you assume the alpha is 0.01. And the one way to understand is you actually do run your topics and you look at, for example, if there are too many, what we call boilerplate topics. So for example, if you have topics that are adding up that doesn't make any sense, you have like 5 or 6 of them, that means you might need to go with a smaller one. But when you go with a smaller one, I think it is also important to look if it's over becoming a bigger umbrella. So it's containing a lot of information that could have been 2 topics. So in this case, it becomes a very much researcher decision. It's not, so this specific method, it's not a one-on-one matrix. The other method we use, that actually gives you a literal second derivation score, and you can actually say, yes, this is my optimal topic. So I will say that. So like with everything, that was more complicated. So I assumed I didn't want to go with that, but I'm more than happy to email and we'll talk over that one as well, if anyone's interested. So in this one, even though it's 22, we will now do 5 because this is a class and we really, visualizations look much better with 5. I do recommend you guys trying it with the larger one when you have your own time, or like trying. So yeah, we're gonna do 5, unfortunately. So what we're gonna do is we're just gonna, so since we decided, we're gonna say, let me take my COVID LDA and now create a variable called COVID LDA and make it an LDA with k equals 5. And then this control C saves your variable. So you can, I do 1, 2, 3, 4. You could do whatever number you want. This is just a random number. You can always do it. And then I always save my files as RDA, by the way, because that saves it as the object itself in R. The only bad thing with RDA is it's very hard to convert to other languages. So if you're going between Python and R, I would use different objects in general. And then you can see my LDA is a topic model with 5 topics. So again, if you want to do more complicated, you can set your alpha number here. If you know, so you can set an alpha number for hypertuning. You can set it for Gibbs. So there are other complicated things you can do. I always say start with the easier method and then build upon it, like test yourself, play with it, go on and add more. I think it's always better than starting from very hard. So the first thing we're going to do is, because we've been talking about terms and documents. Oh, question? Yeah.
What's the alpha parameter?
There is a question. What is the alpha parameter?
Yeah.
So alpha parameter is a hypertuning parameter that goes into the latent allocation direction. So it's an algorithm number that it looks at the closeness. So it literally detects the closeness. So you can, and it differs. Some corpus with larger text require and higher alpha, where tweets require a lower alpha, for example. But like I said, for that you should run the other methodology, and that will actually give you the optimal alpha number as well. It's really. But in the scholarship in general, in computational text analysis, using 0.1 is also accepted in this, as I've used it in this case, as a general alpha number to use.
Another question about the seed parameter. We use the seed parameter for example, just having the same result every time you run the algorithm.
You should talk in the mic here, because otherwise it's very hard for her to listen. Yeah. Sorry, but that's
Yeah. I'm just asking for the seed parameter. It's for just how can I say that? Just having the same result every time we run the algorithm. We use the seed parameter for that reason.
So I mean, if your text is the same, you should get the same fine case tuning or cross validation. Yes. And when you run LDA with the same parameters, you should get the same number of topics. The word order and the topic order might difference because LDA is iterative. So you might get topic 1 come up in topic 5, but the words will be the same. So that's why you should always use the first one, like the one you saved to run, and not run it over and over, because it will mess your future analysis, which I'll show if you're trying to match it, because it will, the topic order will change every time you run.
Okay, thank you. But the results the same.
The results, yes. If your data is the same, the results should be the same. If it's not, then there's an issue or there's a glitch that you should look into.
Okay, thank you so much.
You're welcome. And I did just run this one again this morning to see, and it was exactly the same. So, so the first thing we want to do is we want to extract top words. I guess that's what we're all interested in. We're interested in so we ran all of this, we did all of this. What do we get out of it? So this one is not, by the way, so you can see the first word we get is Chicago and mayor, because that was the first words of the first text we had. So this is not an ordered list. So this is just saying, use tidy to use the beta numbers, which is the term weight, the term probability per topic. And I'm saying, just make a document that has the topic number, the term name, and the beta number. So now I can do different things. So now I can say, okay, so I'm now saying I have this document, topic, term, beta. And now I'm saying group by topic, and then slice the maximum 10 beta. So I'm literally saying, take the 10 top words for each topic. And then I'm saying ungroup, and then I'm saying arrange it by topic, and then in a descending order of beta. So first of all, like we were talking, you can see 5 is a very small number for this corpus, right? Because our topics look very similar and very large. So when you run the 22 model, you'll see the difference. But for our purposes of class and for visualization purposes, it was very hard to fit 22 topics in one slide in general. But you can see topic 1 is about COVID-19, new variants, cases, coronavirus. We have Delta, health, vaccine, death. Similarly, topic 2 is vaccine, mandate mask vaccinated, get new vaccination, COVID, Texas. Topic 3 is mask, and then topic 4 is stimulus bill. You can see it's pandemic news, stimulus, Biden relief. And topic 5 is COVID-19, vaccine, the president again, positive, Joe, pandemic, Fauci. So the other things you could do is you could do top 25 words by changing the N, for example. You could do slice minimum if you're interested in the least. Maybe you're interested in what words are offshoots, what words shouldn't appear. You can, you can do 25. You can filter by topic. If you're interested in only topic 1, you can put a line there that says filter, only topic that equals to 1. So there are different things that you could do. Okay. And yeah, if you're running the code, you should all see the topic visualization in your R. I'll show it to you. It will, as you can see, it will be in your little screen here. And like I said, we can change this to 25, for example, and then we can run. So see, now it becomes visually a bit more difficult. We could do filter. We can do filter topic equals to 1, for example. And we'll just have topic 1. Is everyone okay with this part? Perfect. Okay, cool. So currently you saw our topics are just labeled 1, 2, 3, 4, 5. So I like labeling my topics and knowing what my topics are about when I'm going to do analysis. So in this case, I labeled them very generously, I would say, as you can see. And then the way I actually do is I just add a list column. So I put the topics by order. So I said variants, topic names by order, variants, vaccine mandates, pandemic regulation, relief, COVID-19. And can anyone think why I use underscore rather than space in some of these? Well, so the reason is very simple. In R, writing with space is very difficult and it usually leads to glitches. You need to put the single quotation mark that's under your tilde when you're writing with spaces. But when you write with underscore, you actually don't have the same problem. So I would recommend always using underscore, or there's a janitor package called clean names that actually automatically changes everything with space to underscore as well. So now what we're interested in is, so because remember in the beginning, we said that from R, we get 1, the clusters of words of topics, which is what we did, but we also got the distribution of topics by document. So how do we get that? Anyone have any ideas? So one thing we do is we actually extract the gamma value. So the gamma value is per document for topic probability. So it's the value that says this document has this much probability coming from this topic. And this value estimates the proportion of words that belong to that topic. So similar to what I did before, remember before I said gets matrix beta, now I'm saying gets matrix gamma. So very similar comments, very similar, I'm just changing. And in this one, you can see it gives me the document number, the topic, and then it gives me a gamma value. So what I now want to do is, because I have this document number and because I have this topic, why don't I join it with my original bigger data set, right? Because my bigger data set had dates and it had domains. So if I'm going to do more analysis, if I'm interested, for example, what date, what topic increases, or which domain talks about what topic, I need to join it with my bigger original document, right? Okay. So what I want to do is join the COVID document, so this, with my data. But when I look at the dimensions, you can see they're different. One of them has 7,500 rows and one of them has 1,500 rows. So I cannot join them at this point, right? I cannot join because we don't have the equal amount of, because what I'm trying to do is I'm trying to join them side by side. I'm trying to add the columns from this to the columns from my original data set using my index. Which is why I actually made it equal in the beginning. So what I need to do is I need to make my document wider in this case, because my document is long, right? You can see it's almost 5 times as long. So I need to make it wider. And this is a similar concept again in Python. I don't know if you worked with it. It's you make your documents wide. So for it, I use dpylr's pivot wider. It also has a pivot longer, which we're going to use later. It is one of the most common things I use in data wrangling and also in plotting and visualization. So I really recommend playing with this and learning and like making it almost your learning about it more, playing with it. So, and it's pretty straightforward. So what I'm saying is I created a new variable called COVID documents wide. And I'm saying, get my COVID documents from here and add all the names to topic and all the values to gamma. And now my new document has exactly 1,500 rows because it actually made each document one row, one variable, and then it made the topic number and the gamma value as wide. And my dimension is 1,500. So now I can join them. And I can join them in 2 ways. One is, this is the way. So one is I can actually change my column name to X1, because again, numbers are hard in column names, or I can add my column names that I actually created before as topic names. So both ways work, both ways are fine. I'm going to continue with using X1 just because it's more universal and you can apply it. But in my own, I usually go to my actually name. So what I'm doing is I'm just joining. So to join, I'm saying I'm using the command called left join. So can anyone think what left join is? Why is it called left join? This is a very quiet class, people. So left join is I take my data frame on the left and I join the one on the right to the left. So I don't lose any rows from the one on the left, any information. So in this one, I'm saying join left with the word index and join it by COVID documents wide. And I actually did get an error. And can anyone guess why we had this error? No, 0?
Data types?
Well, yes, so it's the data type. So because my column index was numbers, but my column document, when I pulled it from the COVID LDA, it actually came as characters. So what I'm actually saying to R is join apples and oranges, and R is telling me I cannot join a number with a character. So what I need to do is I need to change one of them. And this you can do, either you can change both of them to character or both of them to number. It really is up to you. There is no right or wrong answer to this one. So what I did in this case is I took my document and I changed the document number to numeric so that they're both numbers. And you can see I said mutate, which is create and rewrite. document as numeric as document. And then I asked what type of it is it, and it's double. And you can see in the above error, it says X index is double. So now my Y index is also double. So when we try it again, now it works. And you can see now I have the index, I have the date, I have the source domain, I have my original text, I have my text, but I also have X1, X2, X3, and X4 and X5, and I have each of their gamma numbers. So now do you see how my corpus, I could do a lot of things? I literally was able to join my topic model numbers into my original document. Okay. So now what I'm interested in, as you can see, there's a column called source domain here. And you can see I have Fox News, Daily Wire, ABC 13, Live, Fox 13 News, HuffPost. So I'm actually interested in to see what source domain talks about what topic most, right? Is there a choice or are they all equally? So to do that, I literally said, first take source domain and X1 to X5, and then group by source domain by summing all the gamma values of source domain. So I'm saying take all of the ones that are Fox News from X1 and sum them up and give me a single value. You can do mean here, you could do sum here. It really depends on what you want to do. You just got to change the saying the word. And now we have 472 rows only. So now I only have one row for each of my domains and one gamma number. Okay. Okay. So let's do topic 4 and the top 10 domains. And yeah, I just picked something. We can play around with it if you want. So I just said, take topic 4, I created a variable called topic 4. And I said, take my document called domain and slice the maximum 10 and give me what it is, the head. And you can see in topic 4, the maximum domain, the domains that use topic 4 are NBC News, New York Times, CNN, Washington, CNBC, and Daily Wire. We can play around with different ones, and let's do some hands-on since everyone's quiet. Okay. So we can also, so for example, let's pick topic 1 and then let's do top 25. And then should be topic 1. So you can see now topic 1 comes mostly from Fox News and CNN, but it's very equal. New York Times, NBC, Reuters, Daily Wire, Breitbart, New York Post. So you can see that there's actually much more center right news channels, as well as left and central news channels in topic 1. We can also do slice minimum. Let's see which, and then let's change this to topic 1. So see, and the topics come from kojo.com, which I have no idea, AV Club, Bangor, The Daily News, American News, Vanity Fair, Trillis, SF Eater. So very, very now you can see very small topic probability, but Eater has a very high topic sum in X2, for example. Is everyone okay with this?
The problem is that you need to. I think the better option, if someone will prefer, is to log into the Zoom now and you also write questions or speak to the laptop.
Hi. So my question: what do these gamma numbers mean substantially? So they are not percentages, but like I see 11, 9. What do they mean in real life, let's say?
so they're the summation of topic probabilities. So this is because we summed it up, they go below 1. But when we looked at it here, you can see they're always between 0 and 1. So they're probabilities per each document. So when you sum it up, because we're summing up each probability, we get a number that's more than 1. A better way would be actually to mean this. I will say that, I think, if you want to see more of a so you can just do mean and then domain and then domain. Now you can see that it's not, as you can see, these are now the mean numbers for each domain. So they're between 0 and 1. So, and it depends on what you wanted to do. So what I was interested in today, when I was trying to show you, was more actually the volume of topic probabilities. So I was interested in the volume rather than the mean topic probability. But if you're interested in looking at the mean topic probability across domains, I would do mean. If you're interested in the aggregate topic probabilities, I would do sum. So it's really, and that's one good thing to actually know with even with computational, your research question drives your code always. It should never be your code drives your research question. It should always be your research question drives your code. So is that better? Is that clearer?
Yeah.
Okay.
Yeah.
And the other thing that you can do is you can always do summary, for example, domains get column X1. And it will give you the minimum, the maximum, the medium you can see. So if you're just interested in like the layout of your variable. So yeah, so today my research question was to show you the overall volume, so I aggregated it. But if I was interested in more how each domain, what was the topics across time, or what was the topics, each domain's engagement with topics across time, I would have done mean. So. So now, as you can see, we have 472. So I just wanted to show you some visualization. So I'm just going to pick 2. And I just picked CNN and NBC News, but we can play around with other ones if you have any suggestions, if you want to see anything else, for example. So I just want to compare how CNN and NBC News in sum deal with topics. So I just filtered source domain CNN or source domain NBC. And you can see my new little tibble is only has CNN and NBC. So now, in order for me to do a bar graph, I need to change my data to longer, because you can see this is a wide data, right? Because we did change it to wider before. So now we have to change it to long in order to graph it. And longer is also very similar to how we do. We just say pivot longer, and I'm saying pivot longer from source domain. So I'm saying I want source domain to go as my main, and then send the names to topics. I want topic numbers in one column, and then gamma in one column. And now I have, as you can see, a longer one rather than a wider one. Now I only have 3 columns. So now I'm going to graph it, and the code of the graph is in GitHub in the code itself. But now you can see how the differences between CNN and NBC. And you can see, for example, in X5, CNN has a higher aggregate, while in X4 and X3, NBC has a higher, talks about the topic more, and X2 and X1 is again CNN. And these are 2 very similar news channels. So if I, for example, if we wanted to compare, like do different comparisons between Fox News, between Breitbart, Those could show maybe different results. Those could also show similar results. You never know before running it how this works. Does anyone want me to run something, or does anyone want to run something themselves and then talk about it now?
Sorry, yeah, you mean if someone is trying to run the code, or I think I don't know if there are questions on this.
Okay. Yeah, and you can see the code here. This echo false, by the way, just means that it doesn't show the code on the slide, but it shows the result. So if you remove that, it will show both. That's the show. Okay, let's continue since I only have half an hour left, I think. Okay. So you can also play with graphs. As you can see, I put now our topic labels in instead of using X1. So now I know what each of these topics represents. So I played around with the theme a little bit. I made it, this is a theme called Wall Street Journal. So it's graphs similar to the Wall Street Journal graph, which I like. There's many themes, multiple themes. You can play around with it. I will say ggplot and ggthemes is like a rabbit hole. Like it's once you start playing with it, you just find so many things. You can play with the colors. There's many color palettes from Wes Anderson to now there's something called Natural Park, which is beautiful. So you can play around with colors. Yeah. So you can do different things. And I added some to the code so you can play with it. So now let's do topics over time. So for topics over time, I'm again interested in my main, I'm going to take my main one. And at this time, instead of taking domains, I'm taking dates and my topics. And in this one, as you can see, I actually I wrote some wrong. I used mean actually in this one. And the reason why is because I'm not interested in the overall sum of topics per day. I'm interested in the average topic probability per day and see how it goes up to see. Because I'm not interested in if there was 10 more articles. I'm more interested in if all of the articles, an average talks more about a topic. So now my research question changed. And again, I did the same. I pivoted longer, this time by date. So you can see the date repeats, the topic number repeats, and the gamma value repeats. And then I visualized it. Even though I have 5, because I have 5 in every day, this is very crowded and this is very confusing. And visually, it tells me very little story, right? It only tells me that X1, like there are some peaks here, but I don't know what's happening in this portion of the graph. Okay, so what I'm going to do is I said I want to do a simpler graph. So I'm only going to select topic 2 and 4. But again, as you can see, this is very confusing. We have a clearer picture, but it's still very crowded. So what I was interested in, I said, okay, if daily is doing this, what if I do it monthly? What if I want to see what happens monthly? And for that, I use the zoo package, and it's year month. It's as year month. And you can see I only use the zoo package once. So I will only use, rather than loading it, I did load it in this case because you guys are running, but usually I wouldn't have loaded it and I would just pull the package in this specific instance because I'm only going to use it this once and never again in my whole code. So what I'm saying is create a new column called year month and take my date column, change it into year month, and then change it into month year. So I'm literally saying change it into year month and then change it into month year. So what it does is it just makes everything. You can see either January 1st to February 1st. So it just changes all the dates in January to January 1st, changes all the dates in February into February 1st. So it just creates one variable per month. And then I'm saying average that, again, like before, and then make it longer again. So this time you can see I can actually understand the picture a bit better, right? you can see there's a clear rise in X5 at the end towards January 25, and there's a drop in X4 and X2. And then X1 is pretty stable, and X2 goes down. X3 kind of mimics, also goes down. So this makes more sense, as you can see. This makes more visually sense. We can see more, we can actually draw conclusions from this more. Okay, so now this was my presentation. Does anyone have any questions? Or does anyone want to go over the code? Anything in the code that they didn't understand?
Well, first of all, thanks so much, and for the presentation. So yeah, of course, yeah, the floor is open for questions from the audience. Yeah, one question. Please. Yeah. I know it's yes.
My first question about you changed something, I think echo, that there's a parameter.
Oh, yes. So I can, yeah. Let me show you that. Yes, this one you mean.
Yeah. I think, what's the function of the echo here?
So this is our markdown. So this is what I write to actually, and then I create init, and then it creates the slides I just showed you. So, and this is completely a static thing. So when I change echo, when I remove echo false in this slide, let me show you. So in this slide, it will show the code of the graph as well as the graph. So aesthetically, I just wanted it to show the graph, not the code.
Okay, I see.
So, but if you want, for example, in your own work for it to show the code and the graph, I would just remove that echo false. So it will show, so this is, for example, does not have echo false. As you can see the code.
Yeah, so this is a bit tricky in the sense that she used the code to generate the slides as well, not the figures, right?
So it is not the issue that we shouldn't.
Yeah, I mean, if you can run the code without considering the problem of showing the code and the charts, because
Okay.
but this was her problem because she wanted to make the slides with the code. Yeah, am I correct?
Yes, you are. And if you're going to run the code, you have no problem. You don't need to change this. So as you can see, if you run this, you will see this here.
My second question is about the rating. You use the frequency for just generating the matrix. Can we use the other ratings, for example, for the TF IDF for topic modeling here, or other, and if we use the rating, it changes the results.
Oh, so you mean instead of using
For the tokenization, I see that the rating term frequency, for example, we can we change it? Of it is a default, or if we change it, for example, using the TF-IDF, does it change the results? The rating actually changes the result. I mean.
Yeah, it will change. Yeah, it will change. I mean, that's very yeah. I mean, that is the short answer. It will change.
Which one is the best? You think just the term frequency, or just using the TF-IDF for rating? I don't know.
I mean, these are like, let me tell you this, these are questions we face every day when we're writing papers. And like, what kind is better? Also, is like structural topic modeling better than LGA or better than BERT topic model? I will say, what I do, I can tell you what I do. And I think that's, so I take a sample of my corpus. Usually I take like 0.01, like very small corpus, or I take like 1,000 texts like I did in this one. And I run all of them. And then I compare visually with another coder, with another co-author usually. And then we decide which one we want to go with. So it really is, there's multiple papers, multiple comparisons. I personally do not feel strong enough to claim one is better than the other. I think it really depends on your corpus. And since the other thing that we should not forget is, and I think that's important, we're using a computational method where we're using text created by humans. So this is not a computer robotic text. We have, and it changes a lot. Like I said, doing tweets is very different than looking at news articles. It's very different than looking scholarly articles. It's very different than looking at the forum posts. And when you go from different, and it's also very different when you look at, for example, when you look at scholarly articles, the toning is different, the word use is different, and the other ones you have, you know, emojis, you have different things. So my advice is always sample, run, and then decide which one you want to go with. And you can put that in a footnote, or you can put that in an online supplement. You can say, I ran these and I picked this one for these following reasons.
Okay, and comparing to, for example, different weighting methods, can you use the perplexity, something like that, for comparing?
So in this one, I use, you're talking about picking the topic number, or?
I think there is an index like that, perplexity or something like that. Yeah, I mean that, for example, I use TF as a weighting, and then I use TF IDF as a weighting, and then run my model and fit the model and get the results. And then you compare the perplexity of these two.
Yes, you can. Yes, exactly. That's actually a similar method to this one. You can do. That's one thing you could do. Like I said, I use cross validation personally. Not this one, which is a bit which requires paralleling and a lot more packages. That's why I didn't show it today. More than happy to send you the code. That actually runs different perplexities with different alpha numbers, and it gives you a second derivative number that actually is the it gives you a second derivative perplexity, so you can actually say that when it hits 0, that's the one you pick. So, like I said, that's a bit more complicated and it requires a bit more R use. So that's why I didn't choose that one today, but more than happy to share it with you if you're interested.
Thank you. It's a big issue for me. Thank you so much.
Yeah, of course. Yeah, just send me an email. I have my email in the last thing. Does R automatically determine the number of topics and passes? Did you give? No, to Turkar's question in the chat. So you can see in this specific one, I actually did say K equals 5. So I did give the topic. R does not automatically. Yeah, R does not. Birth topic does when you set it to automatic. I haven't seen an R that. So I actually did put, you can see here, K equals to 5.
So thank you also from my side. So what would you say is a typical range of topics one would encounter in papers you like? So would you say like, so what is the number we can expect when these models can deliver and resolve?
So that is a very good question. So I've done models with I will say 30 topics, and I've done models with 180 topics. For models with 180 topics, I actually run another network on it to cluster the topics because it's much easier to analyze. But I don't think there is I don't think I can give a number. I will say that. And yeah, it is always good to have like 50 because it's easier for the researcher. I just coded one that was 80 recently. It took a long time. So smaller is always makes it easier on your life, but it's not the case. And that was 1 million tweets. For example, that was not 1 million tweets. That was over 8 million tweets. So yeah.
35 to 180 already. I mean, like that's a good estimate, or that's a good number we can work with. So one thing what we heard in one of the previous sessions, I'm not sure if you have been live there, is that many things considered machine learning can be considered as a form of dimensionality reduction. And it strikes me that topic modeling seems to be also a little bit falling in that direction. It seems to be an unsupervised dimensionality reduction where we reduce a V times D-dimensional matrix, so where V is the size of the vocabulary and D is the number of documents, to a D times K-dimensional matrix, where D again is the number of documents and K is the number of different topics there are, which gives us per document the distribution over topics
And then a second matrix that falls out of that thing is a K times V-dimensional matrix that gives us per topic the document distribution or the distribution over different per topic, the distribution over different terms. For that dimensionality reduction to work, what would you say is the typical range or size of vocabulary that you can recommend? So if we, for example, use something like TF-IDF, we might have some cutoff, or if we handcraft our vocabulary, we might have some idea like how large our vocabulary should be. So what would you recommend is a nice number for the size of the vocabulary? What would you recommend is a minimum number of documents that are needed to run that method? Can you give us some recommendations there?
No, that is an excellent question, and I'm just trying. So I don't think I can give a single number. I'll tell you that, but I can say it doesn't work well with small documents, like you like exactly just like you explained very beautifully actually. You need but I personally cannot say if it's 100 documents or 1,000 documents, because it could be 100 documents of books. So you can literally have 100 book level text, or you can have 100 tweets. So I can say it's not going to work well in 100 tweets, that's for sure. But it might work really well in 100 books because you have so many words in each of the documents. So yeah, I don't think I can give you that number, but I take this as a challenge to work on different matrix and try to see it and try to find a number in my summer non-free time. But yeah. Yeah, thank you for that question. Yeah, I think that is a very good question. And that is exactly it. It is another way of looking at dimensionality, reducing dimensionality in this case.
Thank you.
Thank you. Yeah, and regarding, for example, the network, the paper we did with Mikeda, actually, that's the method we chose. We actually did the topic model, and then on top of it, we ran a community detection network to see how the topics clustered with each other. And then we did our analysis from those clusters rather than the topics themselves. And in that, we looked at Italian newspapers. So,
any other questions from the audience or from online?
oh yeah, and then this is my email. You can also, yeah, my name is not very. You can Google and it comes up usually. But yeah, for those of us that that wants to see the more complicated cross-validation code, please send.
Can you hear me?
Yeah, I can. Yeah, I can.
The connection, but now it works.
Oh, okay. Sorry. I was saying, this is my email. For those of you who want the more complicated topic model code, please send me an email. I'll send it to you. Or if you have any questions on the GitHub code itself for the class, also let me know.
Okay, great. Yeah, we do see it. So yeah, and also the slides are on the GitHub, right? So you can see it. Okay, so well, thanks so much. And yeah, if there are no other questions, so yes,
Thank you so much for having me. Wish I was there.
Yeah.